In this quick start guide, we'll look at how to set up and apply grass to your landscape in Unreal Engine. By the end of this tutorial, you'll know how to create, configure, and automatically spawn grass meshes, making your terrain look lush and fully covered. You'll also learn the key settings that help you shape your grasslands to match the style of your project. The Open World Demo Collection Content Pack that we will be using is compatible till Unreal Engine 5.2. Create a new project, or you can use any of your old project from the Epic Games. Let it load. By this time, we will download the Open World Demo Collection Content Pack. From the Epic Games launcher, go to Fab Marketplace and search for Open World Demo Collection, and click on Add to Project, and the project that we will use. If you are not able to add this from here, then you can go to the Library section of the launcher, and under Vault section, locate the Open World Demo Collection. Create a new level that uses the blank default template as a base. Add a new landscape actor to the level. In the main toolbar, click the Modes button and select Landscape to display the Landscape panel and toolbar, and then click on the Create button. To help better show off the grass tool, we are going to add some noise to our landscape terrain, so it is not completely flat. In the Landscape Toolbar Sculpt tab, click Noise from the tool list. Set the noise properties with the following values. To help better show off the grass tool, we are going to add some noise to our landscape terrain, so it is not completely flat. In the Landscape Toolbar Sculpt tab, click Noise from the tool list. Set the noise properties with the following values. Then start painting the noise with this brush. Create a folder inside the content browser. Then open this folder and right-click in the content browser. From the displayed context menu, go to Foliage, Landscape Grass, type and name it. Double-click on Landscape Grass type. And once opened, press the plus icon. That is to the right of the grass variety's name. Inside of the landscape grass type actor, look for the grass mesh section. Click on the input box and enter sm_fieldgrass_01 as the search term. Then load it as the grass mesh. With the static mesh added, we need to set the following properties to ensure that we are spawning enough grass mesh and that those meshes are randomly rotated and aligned to the landscape terrain. Create a new material for our landscape terrain by right-clicking in the content browser, then selecting the Material and Textures option from the Create Basic Asset section and rename it. Open up the material by double-clicking on the material inside of the content browser. Then we will add textures from the Open World Demo collection to the material graph. Right-click and search for texture sample. Add the following two textures from the Open World Demo collection to the material graph. T_alpine patch 001 _sir and T_grass 01 noisy alpha. Right-click and search for Landscape Layer Blend. Select the Landscape Layer Blend node, and under the Details panel in the Layers section, and add 2 new layers to it by clicking the plus icon 2 times. Once 2 layers have been added, set the layer name of one to Grass, and set the layer name of the other one to Rock, also setting the preview weight to 1.0 for each. Connect the T_alpine patch texture to the layer rock input on the landscape layer blend node. Then connect the grass alpha to the layer grass input. Finally, connect the output of the landscape layer blend node into the base color input on the main material node. Now right-click and add landscape grass output node. In the material, under the grass type option, press the arrow icon to load the actor that is currently selected in the content browser. You can also drag and drop it here. Now right-click and add landscape layer sample node. Select the landscape layer sample node under the parameter name right, grass, and connect the output from the landscape layer sample to the input of the landscape grass output node. Select your landscape actor. Apply the new grass material to it using the Details panel. Switch to Landscape mode. Go to the Paint section. Under the Target Layers section, add a new layer info by pressing the plus icon. For both the rock and grass layers, create new layer info assets when prompted. Select the grass layer. Begin painting on the landscape. Wherever you paint, grass will automatically appear. Keep painting until your terrain has the amount of grass coverage you want. Unreal Engine now auto-generates grass across the areas you painted. The result is a thick, natural-looking field of grass, created quickly, efficiently, and without manually placing thousands of meshes. Next, we'll explore how to use the Procedural Foliage Tool to generate a full forest in Unreal Engine. You'll learn how to create, configure, and spawn trees and plants, all procedurally. By the end, you'll have a level populated with natural foliage. Make sure you've enabled the Procedural Mesh plugin. Then, go to Edit, Editor Preferences, Experimental, and check Procedural Foliage. We already have the Open World Demo Collection from the Marketplace. Save your level and content. In the content browser, right-click, Foliage. Create a procedural foliage spawner. Rename it. Drag the spawner into the level. Scale the spawner volume to cover a large area. Then create a static mesh foliage asset. That represents a type of tree or plant you want to spawn. Open your procedural foliage spawner. Double-click it in the content browser. In the spawner settings, add a new entry to the Foliage Types array. Click the plus sign. Assign your tree static mesh foliage as the foliage type object. Open tree static mesh foliage asset and set its mesh property to a static mesh. For example, hilltree_02 from the demo collection. Return to the level viewport, select the spawner, then under its procedural foliage settings press Resimulate. A forest will be automatically generated. Inside the spawner volume, you should see many trees densely populating the area. After resimulation, rebuild the lighting via the main toolbar build, because many static meshes have been added and lighting needs to update correctly. Under placement, enable align to normal and random yaw, so the trees follow terrain slope and have random rotation for variety. Under procedural collision, set shade radius, e.g. 50. This controls how close trees can spawn relative to each other, avoiding overcrowding or overlap. Under clustering, you can change number steps if you want uniform-sized trees, same age or size, comma. If the forest feels too dense, reduce initial seed density, e.g. to 0.25, then resimulate. This gives fewer, more spread out trees. To grow a multi-aged, more natural forest, increase number steps, e.g. 3. This simulates growth over several years and produces variation in size and distribution. Under growth, you can adjust parameters like max age, how long trees can grow, and procedural scale max, maximum size variation for trees, to get variation in tree sizes. Under instance settings, cull distance, set a high max value, e.g. 20,000, so distant trees are culled properly, helping performance. Once you are done with the changes, resimulate to update the forest. To make your forest look more natural and less uniform, duplicate your existing static mesh foliage asset. In New Tree, change the mesh to another tree mesh, for example Scott's Pine Tall _01. Open your Procedural Foliage Spawner, add another entry to the Foliage Types array, and assign tree _01 as the new foliage type. Resimulate the spawner. Now you'll have a mix of tree species populating the same area. For the new type, you can tweak settings, number steps, initial seed density, spread distance, shade, growth, scale, overlap priority, etc., to influence how and where they spawn, how dense they are, and how they grow over time. You'll get a richer, more varied forest layout with mixed species, sizes, and distribution, much more realistic than a uniform forest. If there are parts of your landscape where you don't want trees or foliage, use blocking volumes to exclude areas.